Hi, in this video we're going to look at transforming graphs by a scalar. So we're going to be thinking about multiplying it by a or multiplying the x value by a. So what we've started off with again is the sine graph, which is roots of 0, 0, pi 0, 2 pi 0, and minus pi 0, and maximum values of pi over 2, 1, and minus pi over 2, 1. If we're multiplying it by a f of x, what's going to happen is we work out the sine of x first of all, and then multiply the values by a. And whenever a is equal to 2, let's see the effect on that. What we can see is that all the y values have been doubled. So 0, 0 is still there. This point, the maximum point is pi over 2, 2. And compared to the red graph, the sine graph, that was pi over 2, 1. We can see the effect is that the y value has been doubled. And that's going to be the same for the minimum value. So we've got minus pi over 2 minus 1, and that's been stretched down the way to minus pi over 2 minus 2. So the effect that a has on it is that it stretches it parallel to the y-axis. So we can change a to any value we want, and we can see it's just stretching it parallel to the y-axis, taking the x-axis as the center of that stretch. And the same happens for a negative value. It will stretch it in the other direction by that number. So if we've got a value of 6.3, it's been stretched vertically to pi over 2, and it's going to go to 6.3, which we can see. So that's whenever a is outside the bracket. Now what we want to look at is whenever a is inside the bracket. And what we're really doing there is we're multiplying the x by a first of all, and then we're multiplying it applying the sine function. So x is then doubled, and then we're applying the function. So let's see what the graph of sine 2x will look like. And what we can see is that the points, so we've got one full cycle of pi and of sine in red, and within that we now have two full cycles of sine 2x. We can see that the peak was at pi over 2 and 1, and the peak of the blue is now pi over 4 over 1, so the x value has been halved. We can see the first root on the sine graph is pi over 2, and the first root is pi over 2 in the sine 2x graph. So what's happened is it's been squashed parallel to the x-axis from the y-axis, which doesn't move. The other thing to note as well, that if we change this to 3, then it's going to be a third of the way in, but we can see that there's actually 3 full cycles of the sine graph within, or the sine 3x graph within the original sine graph. So whatever that number is, it tells us how many graphs there are going to appear. It also tells us what we do to the x value, and the x value then is going to be divided by 3. So again, if we look at the x coordinate of the maximum value, we know to be pi over 2. If we divide that by 3, what we should have is pi over 6. And that's what we can see clearly. The first root on the x-axis for sine is pi, and if we divide that by 3, it's going to be pi over 3, 0, which again we can see. So the f of ax stretches it horizontally by a factor of 1 over a. So let's see what happens whenever a is a fraction. So if we change that to 0.5 or a half, then we can see that it's been stretched longer. So rather than shrinking, it's been stretched out. So the root, or the maximum value, again we know is pi over 2. The effect that that's had is that it's now pi, so it's been doubled, which is the same as dividing by a half. First root was at pi and 0, and then that's been doubled to pi over 2. And we can see as well there's only half a graph in the blue, the half of the sine half x graph in the full one. It would be the same with the quarter. If we went to 0.25, we'd only have a quarter of the graph in a full cycle. So that would be 2 pi and 1, which has been stretched 4 times.